June 3rd, 1998. On a calm morning, a German family was enjoying coffee while traveling on a train. This high-speed train was going from Munich to Hamburg. It was around 10:30 in the morning, and everything was normal so far. But exactly 12 minutes later, that family was terrified when suddenly a piece of steel tore through the floor beneath their feet, right between their seats. But this was only the beginning. The beginning of the most dangerous accident in the history of German high-speed trains. Welcome once again to Noble's Creation. Viewers, in the late 1950s, Japan shocked the world when their Shinkansen, also known as the bullet train, became the world's first high-speed train. This train connected cities across the country like never before and made travel so fast that journeys of hours were reduced to minutes. Following Japan, France and Italy also built their high-speed train infrastructure. And Germany did not stay behind either. Germany started its own high-speed train project called ICE, meaning Intercity Express. When these trains came into public service in 1980, the world believed this was the future of trains.
Every possible feature that one could imagine was included in them. Aerodynamic design, use of modern computers, and an extremely comfortable journey. Everything seemed perfect. But inside every perfect system, there is always a hidden weakness. And the weakness of ICE trains was their wheels. The first-generation ICE trains initially had monoblock wheel design, meaning the entire wheel was made from one solid piece of steel. These wheels were strong, cheap, and reliable. But a problem started to appear in these monoblock wheels. After a few years, passengers began complaining that at high speed, the train had strange vibrations. In the buffet car where food was served, glasses, spoons, and forks would rattle due to the vibrations. These vibrations and sounds were making the journey very unpleasant. And when engineers finally checked, the problem was inside the wheels. Although monoblock wheels were made in one piece and were equally balanced from all sides, if even 5 grams of weight increased on one side, then at high RPM, this difference would create vibration.
And that is exactly what was happening. Due to high-speed friction, some sides of the monoblock wheels wore unevenly, which disturbed the balance of the wheel. At slow speed, it was not noticeable. But when this unbalanced wheel rotated at 250 kilometers per hour, the whole train started vibrating. This is actually a common problem in any wheel. Even in cars, if 2 puncture patches are applied on one side, it slightly increases weight and can cause vibration at high speed. To fix this, wheel balancing is done.
Technicians add equal weight on the opposite side to balance it. But balancing a large number of train wheels is very difficult, especially if they are made in one piece. And replacing wheels is not only difficult, but also very costly. So German engineers came up with a new solution for ICE trains, and that was resilient wheels. The special thing about resilient wheels was that they were not made in one piece. The inner ring and outer ring were separate pieces, and between them was a rubber ring that would absorb vibrations. This design was adopted so that when the outer wheel wore out, only that part could be replaced instead of the whole wheel. At that time, this design was already being used in German trams. But the issue was that trams only ran at 30 kilometers per hour, and ICE trains had to run at 250 kilometers per hour. This was a huge issue, the depth of which would be understood later. But at that time, no one paid attention to it. Executives approved the resilient wheel design without proper testing. And in 1992, these new wheels were installed on all high-speed trains. For a few years, everything worked fine. But in 1997, Hanover's tram company, Ustra, discovered something shocking. They noticed cracks in their tram wheels.
They replaced the cracked parts and, as a precaution, informed Deutsche Bahn, Germany's national railway company. But since there were no vibration complaints in ICE trains at that time, Deutsche Bahn ignored this warning.
And exactly 1 year later, on June 3, 1998, everything changed. At 10:30 a.m., ICE train 884 departed from Hanover Station to Hamburg. The train had a total of 14 coaches, 2 power cars, and 12 passenger cars. There were 287 passengers and 8 crew members on board. Everything was normal when leaving Hanover Station. In coach number 1, Jörg Detman was traveling with his family. Their journey was going smoothly. But after a few minutes, something hit the train floor.
And the next moment, a sharp steel piece tore through between 2 seats. This sharp piece of steel was actually a fragment of the wheel. Seeing this, Georg and his family immediately panicked. It felt like the ground had slipped beneath their feet. If that metal had come slightly left or right, his family would not have survived. He immediately sent his wife and children to the next compartment and went to find the conductor himself. The conductor was in the 3rd coach at that time.
Georg explained everything to him, but according to company policy, the conductor could not stop the train until he personally inspected the issue. So both of them started walking toward the first coach. The train was still running at 200 kilometers per hour, and gradually the vibrations were increasing. By the time they reached near the first coach, the train had already traveled 3 kilometers, and now it was about to pass through a dangerous section.
Where the tracks split, the broken wheel piece was still hanging underneath and scraping along the track. When the train crossed the first switch point, that piece fell down and hit the track lever. At that moment, something very dangerous happened. The track switch changed. Now the first and second coaches were on one track, but the 3rd coach moved onto another track, meaning the front and rear were going in different directions.
The train body twisted, and coach number 3 slammed directly into a concrete bridge pillar. This horrific collision destroyed half of the bridge. Coach number 4 managed to avoid the collapsing bridge, but hit an embankment. And 3 railway workers were crushed to death instantly. Coaches 5 and 6 were trapped under 300 tons of falling concrete. Their height was reduced to only 6 inches. Yes, only 6 inches.
The remaining coaches behind, 7, 8, 9, and 10, collided at full speed and folded like paper. Only the first 2 coaches survived, where Georg and his family were, and the front locomotive stopped 3 kilometers ahead. At the moment coach 3 hit the bridge, the engineer and driver did feel a jolt, but they had absolutely no idea what disaster was happening behind them. The accident occurred near a small town called Eschede.
When locals heard the explosion, they rushed to the site. What they saw was something they would never forget. Broken coaches, pieces of metal, fire, and people screaming. Some people were trapped under the bridge debris. Some were stuck in their seats. And the pressure-proof windows were so strong that breaking them was almost impossible. Rescue workers had to call heavy machinery. But even then, it took hours to reach the trapped passengers. More than 1,000 rescue workers arrived at the site. Ambulances and military doctors all joined the operation. Nearby, a medical conference was taking place. About 40 doctors from there also rushed to help. But by then, everything was already over. In this accident, a total of 101 people died. 88 people were found severely injured, and around 100 people had minor injuries. Those in the first 2 coaches survived.
German high-speed trains, once considered the safest in the world, had their reputation shattered
by this disaster. This accident shocked not only Germany, but also countries like France, Italy, and Japan. When investigators analyzed the site, at first it seemed like maybe a vehicle had come onto the track. But when they saw the wheel fragment inside coach number 1, everything became clear. Records showed that the same wheel had previously reported issues.
Flat spots had been reported 8 times, yet it was never replaced. Crack detection machines were available, but inspections were still done visually using flashlights. The company dismissed machine alerts as false alarms. In 1992, a German research organization, Fraunhofer, had warned that resilient wheels could be dangerous at high speed. And in 1997, the Hanover Tram Company had also given a warning, but both warnings were ignored. Engineers later explained that each wheel rotated about 500,000 times daily at high speed. With each rotation, the steel slightly compressed and expanded. This created fatigue cracks that kept growing. And because of the rubber layer, vibrations were absorbed, so no one realized the wheels were cracking. And finally, on June 3, 1998, a single wheel failure caused a massive disaster.
This is considered the deadliest high-speed train accident in history. After this accident, all high-speed train wheels were replaced back with monoblock design. Bridges near junction points were relocated so that such an accident would not happen again. Germany reevaluated its entire railway system. Pressure-proof windows were replaced so that in future rescues, passengers could be evacuated more easily.
Even today, the Eschede disaster is taught in railway training centers. Monoblock wheels may cost more and take more maintenance time, but at high speed, being a single cast piece makes them much safer. And vibrations act as a signal that balancing is needed. We hope you liked this video. Thank you very much for your kind comments and support. See you in the next amazing video.